All right, transition diagrams in sets of three. A researcher studies both the weights of women and their daughters' baby weights. The weights were split into three categories: low, average, and high. The researchers logged the data below. Low weight mothers, 5% gave birth to low weight babies and 45% gave birth to average weight babies. The remaining percentage became high weight babies. So pay attention to that. 5% and 45%, that's a total of 50%. That means that 50% became high weight babies. Average weight mothers, 50% gave birth to average, while the remaining percentage was equally divided amongst high and low. So we take the remaining 50%, we cut it in half. So that is 25% and 25%. And then high weight, 30% gave birth to low weight, 30% gave birth to average weight. The remaining percentage stayed high weight. So there's a total of 30% that's already out, 30% that went to average. That means there's a total of 40% that will stay as high weight. All right, let's draw a transition diagram. And as we do this, we use some separate colors to help us out. So we start with low, we go to high, or average, I'm sorry, and let's go ahead, and after that we are going to have high weight. Okay, so let's start with the information from the low, and then we'll make our transition matrix. So low, we know that 5% stayed low and 45% went to average. Okay, so low, 5%, so I'm going to make a loop, 5% stayed as low, and then we know 45 went to average, and that tells us that the remaining went off to high, which was a total of 50%, which is what we found. Average weight, 50% gave birth to average, and the rest went equally distributed both. So average, we said was 50% stayed, 0.5, so there's our loop for that, okay? And then we're gonna make an edge that goes to each one at 0.25 and 0.25. And then we're going to go off to our high weight, and it says 30% gave birth to low, 30% gave birth to low, so 0.3, and then 30% gave birth to average, 0.3, and then of course 40% stayed in the loop of high. Okay, let's go ahead and do our transition matrix. And remember, as we do these transition matrix, the best way to think about them is terms of now and next. So I like to put those words on there, now and next. And as we're labeling all of our information, okay, as we're labeling all of our information, I want to make sure that I use those colors to help us out. So there's our high, there's our average, and then we have our low. And then I'm going to keep it exactly the same because we're going to have low that becomes low that becomes average, and then low that becomes high weight babies. Okay. And once we've got that information, we just transfer it all into our matrices. So low that goes to low next, it was 0.05. They stay. Low that goes to average, low that goes to average was 0.45. And low that goes to high, which is 0.5. Okay. Then we just go off to average. We say average that goes to low was 0.25. Average that go to average is 0.5. And then average that move off to high is going to be 0.25. Okay. And let's go to high. And so what we have is high that goes to low. So high that goes to low is 0.3. High that goes to average is 0.3. And then high that stays high is 0.4. Okay. Now let's go ahead and keep on working with what we've got. It says 200 mothers participated in a study. 40 of the mothers were low weight. So what we know is that out of the low weight, we've got 40. Okay. And 100 were average weight. So out of those 100, out of those, we've got average, which is 100. And notice what we don't have. We don't have the high weight. They didn't give us any of that information. But that's easy enough. There's 140 right here. So that just tells us that there must be 60 in order to make a total of 200. Now, once we do this, we're just going to make some basic equations off of the next columns. Okay, so if I want to find low next, I'm going to use this column right here. And I'm going to say, okay, well, what is low next? Well, I know that low next is 5% of low. So 0.05 times how many low were there? There was 40. Plus, I need to add the average weight. So 25% of the average, which is 100. Plus, I'm going to add in 0.3 of the 60. And that is going to give me our low. After that, I'm going to follow that pattern and I'm going to go and try to find the average. So let's find our average next. Okay, and I'm going to follow that same exact pattern out. You notice that it comes out. So I have 45% of the low. So 45% of 40. Plus, I'm going to add in 50% of the average. There's 100 of those, so 0.5 times 100. Plus, I'm going to add in 30% of the 60. And that would tell us the average for next. Now let's go to high. If I want to find high next, I just keep working my way across those columns and then work vertically down. So at that point, what we're going to do is I know 50% of low, or 50% of 40, plus 25% of the average, which is 100, 0.25 times 100, and then plus 40% of the high. Okay, so 40 plus 0.4 of 60. Once we've got that information, it is as easy as going back and typing everything in to find those answers. So that's what I'm going to do. I'm going to say 0.05 times 40 plus 0.25. And I'm just going to do this for each one of the categories. So there is our first one. There's 45 that should be in here for low. So there should be 45 babies in the low weight category. We just keep working it all the way across, one at a time. Which is 86. Okay, so there should be 86 babies in the average category. Now we could go ahead and make our lives easy and just subtract it from 200 to find the high. Subtract 86 in the 40, in the 45. But I'm just going to go ahead and type it in just to make sure our calculations are right. So 0.25 times 100 plus 0.4 times 60. Notice that gives us 69. Okay, and what we're going to do is we're real quickly just going to make sure we've got all of them in the circle of 200. So 45 plus 86 plus 69, and check it out, we've got a total of 200. That means we've done our calculations correct. So we started with with all that information, and we went to a transition diagram, then a transition matrix, and then we use that information to find out how many low weight babies, average babies, and high weight babies we should expect after one sequence of birthing.